This is an AS FP1 question on vectors, and it's using vectors to find area and volume. A scientist is investigating the properties of a crystal. The crystal is modelled as a tetrahedron whose vertices are A 12, 4, -1, B 10, 15, -3, C 5, 8, 5, and D 2, 2, -6, where the length of unit is the millimeter. The mass of the crystal is 0.5 grams. Part A, show that to one decimal place the area of the triangular face ABC is 52.2 millimeters squared. So this is the formula to find the area of a triangle when it's like this. For my A and B here, I'll use the vectors AB and AC. You could use BC if you wanted to instead. Right, so let's look at the jump from A to B. So 12 to 10 goes down by 2. 4 to 15 goes up by 11. -1 to -3 goes down by 2. And then A to C. And A to C, so it goes from 12 to 5 down by 7. 4 to 8 up by 4. And then -1 to 5 up by 6. So my area is going to be equal to half the modulus of the cross product of these two vectors, which I'll do as my next step. So half, then the modulus, and then the cross product, I'll just write I, J, K, and then -2, 11, -2, -7, 4, 6. Right, so half modulus of so I times by 11 times by 6, that's 66, minus -8, so that's like 66 plus 8, so that will be 74I. Then for J, that will be -12 minus 14. So -12 minus 14 is going to be -26. Now remember, it's going to be minus 26, so it'll be plus 26. And then for K, it will be -8 minus -77. So that's -8 plus 77. And that gives plus 69k. Right, and we want to find the size of this and do half of that. So it's going to be half of the square root of 74 squared plus 26 squared plus 69 squared. And what I get as an answer is 52.2365, so on. We need to show that it's this to one decimal place, so to 1 dp that becomes 52.2 millimeters squared as required. And part B, find the density of the crystal given your answer in grams per cubic centimeter. Now here's our density, mass, volume formula triangle. We have the mass given in grams, so that's fine. So that's going to be 0.5. Now for the volume, if we have a look, we've got this area here in millimeters squared. This means that the volume that we work out is going to be in millimeters squared, and we're going to have to convert that, sorry, millimeters cubed. We're going to have to convert that to centimeters cubed, because that's how we need to write it, and then we'll do our mass divided by this converted volume, and that will give us the density. So let's start by calculating the volume of this tetrahedron. So as a reminder, here's our formula for the volume 1/6 of the modulus of this triple scalar product. Now if we call B and C our AB and AC, then we've already calculated this part, and we'll do the dot product of this with the other vector that we didn't use, which will be the AD, because all three of the vectors need to be coming from the same vertex, and we've already used AB, AC, so we're going to use AD. So let's work out the jump between the vector A and the vector D. So we're going from 12 to 2 minus 10, and then from 4 to 2, so that'll be minus 2, and then negative 1 to negative 6, so that's going down by 5. So our triple scalar product is just now going to be the dot product of this and this vector, which we've already done the cross product of. So that will be 1, 6, then the modulus of the dot product of this negative 10, negative 2, negative 5, and 74, 26, 69. Right, let's see what we get from that. So it'd be 1/6 of negative 10 times by 74 minus 2 times by 26 minus 5 times by 69, which is negative 1137. We take the modulus of that. So the volume in millimeters cubed is this. We need to change it to centimeters cubed. So that means dividing by 10 cubed. That gives exactly, as a fraction, 379 over 2000. So that's the centimeters cubed. So now I'm ready to calculate the density, and that will be the mass 0.5 divided by this 379 over 2000. Let's see what that gives us. That comes out as 2.638522. Now it doesn't say what to round it to, so 3 significant figures is what we'd normally do. So we'll do 2.64, and that's grams per cubic centimeter, and we've rounded that to 3 significant figures. Okay, let's highlight that.